So the life cycle of extraction is a really important factor to understand. There's lots of different ways to extract. We personally here at Sweet Heel start with the flower, obviously. And the flower within it has a lot of different things that make up the total mass of that flower. Now in the extraction process, we're actually going to go in and reduce what's in there and take certain fractions out. So I'm going to start talking about this at the different layers of what we remove. So starting with the hemp, we begin the process by removing the natural terpenes. And this is the smell, these are the fragrances. These are also used very medicinally, pinene and other things that are out there that are terpenes. These are the same terpenes you're going to find in Mother Nature. So we extract these terpenes through a steamed distillation process. That steam distillation process removes the terpenes from the plant. In its steam is then cooled and turned back into a liquid. That liquid is then deposited into a flask. That flask removes, because the terpenes are actually lighter, they're going to float to the top, and the water is heavier, so it's going to fall to the bottom and create a separation layer. That separation layer gives us our pure terpenes at the top and water at the bottom. From the terpenes, we then take that same flower substance and we bring it in and we put it through an ethanol extraction process. The ethanol extraction process produces what we call a crude oil. That crude oil contains a lot of components that we'll talk about in a minute, but the ethanol process that we use, we take the flour, we put it into a reserve. That reserve has alcohol that has been kept at a temperature of -40 degrees Celsius to -70 degrees Celsius. We take that alcohol and wash it over top of all of the flour. What happens, and the reason that we winterize it, we take it through this process, is because everything that is connected to the water molecule is frozen at that -40 or that -70 degrees temperature. That frozen matter stays tied to the plant. We remove the trichomes, the CBD, the cannabinoids as a whole, and as we remove them, we do still end up with fats and waxes and lipids and anything that sticks to that water molecule, sugars and other things. And that's what's in here. This crude oil is filled with all the chlorophylls and all those dark contaminants, we'll call them for right now. And they're really not a contaminant. They contain omegas and other things that you would actually want within your diet. They're very healthy as a whole. But in our industry, we create a lot of cosmetics and human consumables, and it's very important to have a purity level. We extract crude, but then we take it to the next level of purity. That next level of purity ends up being a pure gold. This is 98% total cannabinoids, so it'll have CBD in it, THC in it, CBN, CBCs, all of the whole major and minors of that profile. What it doesn't have is terpenes right now, because we pulled those terpenes out previously. We put those terpenes back into the natural oil that was created, and this process is done through a wiped film process. That wiped film process, what happens there is we take that crude oil I showed you a moment ago and we put it into a charging flask. So we charge the flask. The flask is charged with our crude oil and it's heated to a very specific temperature. That temperature then allows that crude oil to move through the neck of the short path wipe film system. It's then wiped onto a glass surface. That glass surface is at a very specific temperature. That temperature is where we're going to pull the fraction out of the total mass. Whatever is at that temperature, whether it's the THC, CBD, whether it's the fats, the waxes, the lipids, whatever we're going after within the whole process, that is the temperature that we would set the system to. And so whatever is at that temperature turns into a gas and then is immediately cooled on the finger in the center of the system. It's turned back into a solid, and that solid drips down into one of these flasks at the bottom. Whatever is not at that temperature falls to the wayside, and we then rerun that material. And that's why we do 3 to 4 runs at our material, which gives us the purity of that 98%. And so, coming back to our perfect gold, out of that perfect gold, what I was talking about, we remove our fats, waxes, lipids, sugars, anything that sticks to that water molecule. And that's what this is. This is a byproduct of that end result. And so it's as hard as tar, when it's heated back up to a pretty significant temperature, it becomes a very different consistency. But the cool thing about this byproduct that most people are actually throwing out or getting rid of, we end up reusing. And we reuse it in one of our newest hemp sustainability products. This hemp sustainability product is what we call our Firestarter. It has an incredible acceleration rate. Wind doesn't affect it. We are producing these now for the open market. It doesn't have any smell of hemp because, in fact, we've gone through and refined everything and pulled everything out of that plant matter. And as you see within the plant matter that we have in some of the different points of this video, everything's been stripped of it. There might still be some proteins and there's fibrous mass and there's a couple of other components, but we've removed all of those extra, the CBDs, the cannabinoids, the fats and some of the chlorophylls and the waxes and so forth. And so that's what this byproduct ended up being made of. It's made of our heavy, dense fat waxes and removed product, and it's made of hemp that has been run through this entire process, which gives us the ability as farmers to be able to take advantage of more than just the CBD that we're growing. This plant is an extraordinary thing, and it gives life back to the entire cycle. And by us just having plant matter that we use in a compost pile, or plant matter or fats and wax and lipids that end up being some type of a byproduct that we have to get rid of in some other way, whether it goes out to a plant or a disposal location. So we're trying to use that 100% of what's there. And in fact, we continue on down the story, and we've started to make hemp plastics. These hemp plastics, these are our sample lotions or our travel-sized lotions. These lotions are made from a hemp plastic. That hemp plastic is the jar. We know that we're giving out a lot of samples, and we know that we're providing a lot of awesome products to people, and so we don't want to really pollute the environment. So we've gone ahead and made hemp plastics. Additionally, with our hemp plastics, we've made a mask, so this mask can be reused. The filter that's actually in the mask is additionally hemp. It's a hemp mat, and it has charcoal in between it. So 2 layers mashed together to create a filter. And this mask was a prototype that we put together. We didn't end up going to market with it just simply because there's been a lot of business for the companies that develop this extrusion process. They've been focused very much on the medical industry with our current pandemic, obviously, in producing plastics that meets the need of those organizations as opposed to the hemp plastic. So it's become secondary in the market's demand. And then finally we have one of our other byproducts, or one of our other products that we're working towards, and it's our Hempcrete. The Hempcrete is very strong, very resistant. Now Hempcrete is just a combination of a couple of items. Normally concrete has sands and silts and rocks and other things that are within it. In this case, we only have about 4 major components: water, hemp, lime, and all of that's mixed together, and it creates a nice strong structure. However, it is not as strong as the concrete that's in our driveway. In order to accommodate that, I think you have to be able to mix in a number of other items to be sands and other things. So unfortunately, I'm not a concrete guy. I am just a hemp farmer, and we're trying to find other ways for our farmers to be able to reuse these byproducts.